Hi guys, me again. Once again, I promised you I will show the explanation about PLC, introduction to PLC. Now this video contains those. Let's go to introduction to PLC. Here we are going to see about PLC and its types and architecture and everything about PLC only. Let's see, it's about common thing about PLC. So let's see about it. The definition of PLC comes from its electronic device which is used to control the processor output connected to it based on input and the program given to it. Like an electronic device, it can process the output with the help of input and the program. So this is the basic definition given to an PLC. Let's see the architecture now. It's like the same architecture. The input terminals are here, output terminals are here, power supply and a communication port and a processor inside in it and a memory. There is a two things in here, like input side isolation barrier and output side isolation barrier, which we will go into deep in the upcoming terms. The power supply which we use in PLC will be 230 volts AC or 24 volts DC, which depends on SMPS. So let's see about that. SMPS, switch mode power supply. This is the outlet of the switch mode power supply. When 230 volt AC is given to that power supply to the SMPS, and rectifier will convert the AC to DC, which in the sine wave is converted into DC, which is connected to the filter, which will make the DC output as far as linear. So there will be a less amount of variation in the DC output. So it is again gone to the voltage regulator, which regulates the DC filtered output and gives a regulated DC output, which has no variation in it. The series which we use LM7824 is explained in this way. LM is a series which we use voltage regulator series, and 78 is the output that comes from voltage regulator. It will be positive or negative. 78 means positive, 79 means negative. The 24 is the output voltage coming out from the voltage regulator. In this case, the output voltage is 24 volt DC. Let's go to processor. A processor or a processor unit is nothing but of an electronic circuit which performs operation on some external data source. The external data source will be like input and the program that we given. From that, a processor can perform some operations. The working voltage of the processor is 5 volt DC. Then we can see that from 24 volt DC how it goes to 5 volt DC. In that way, the input side barrier and output side barrier comes to play. In input side barrier, a 24 volt DC is converted to 5 volt DC, which is a working voltage of the processor. In the output side barrier, the 5 volt DC from the processor is converted to 24 volt DC to the output. In input side barrier, we use optocoupler inside the input side barrier. Optocoupler is nothing but of a combination of LED and a phototransmitter. Let's see from here. From input side, the field is given to the SMPS and it is given to the optocoupler to 24 volt, which generates an light emitted, which is a diode which emits light. This emitted light is transmitted to the phototransmitter, which generates a 5 volt DC, which is given to the CPU or the processor. The same way from the CPU, the same way is generated and given to a triac, which generates 24 volt DC, which is given to an output. In here we have used triac, but normally we use transistor or relay. This is the input and output side barrier. It is the input side barrier. Let's see the output side barrier what we use. Relay or transistor can be used in output side barrier. Both in the relay in which AC and DC can be used in a relay, where AC connection can be also given to the 30 volt AC or 24 volt DC can be also given. But the switching time is very slow in relay. Hence, we go to transistor, which is fast compared to the relay, which has a much high switching time than the relay. In relay output, the CPU 5 volt is given to the transmitter, which is given as a 24 volt DC, 24 volt to the relay, which is again connected to output terminals, which is A and B, which is P is connected to the common. We can use to AC voltage here and here by using a load or something. By using another power supply, we can give like that. From the common, we can give the function of the processor. The function of the processor tells about the PLC operating cycle. When a program is given to a PLC, it starts and the input is scanned. The status of the external input terminal, which is a terminal voltage block voltage, is written to the input image, which is an input file, which is a table where all the input that is scanned are stored. Then it goes to the program scan. In program scan, each ladder rung is scanned using the data with the input file, and resulting that the logic is solved and written to the output file, which is also an output image table. In the output scan, the output image data is transferred to the external output circuits, which is turning out the output device on or off. Then housekeeping is made to internally check the memory, the speed of the operation, and service and any communication request which is given from the any outside hardware. So this is the PLC operating cycle which is undergone inside a PLC processor. This cycle time is called as a scan cycle, and the scan time is the time taken to complete this one scan cycle is called as a scan time. Let's go to memory. Memory, we have two types of memory in here: program memory and data memory. Program memory is used to store the program, and the data memory is used to store the input and output data. And we can go to communication port. Communication port is nothing about to upload or download the program to the PLC, or from the PLC to the PC, to interface with the other devices like the PLC, SCADA, PC, and other hardware devices like VFD. Something we can use the communication port, same communication port. Some of the common communication cable we used in industries are RJ11, RJ45, RJ232, RS485, and USB. RJ11 is nothing but a register jack 11, which is nothing but a telephone cable. RJ45 is register jack 45, which is nothing but a Ethernet cable we use in PC. RS232 is a recommended standard 232 protocol, which given by a definition like a serial interface published by the EIA for economous asynchronous data communication over distance up to a few hundred feet. We can use for few hundred feet only. But in RS485, it's also a recommended standard 485 protocol, communication protocol, which has the same definition, but the data is sent through a 2 wires or a twisted pair cable, which allows a greater distance or higher data rates to transmit than the recommended standard 232. And universal serial bus, you know about that. We used to communicate within the PC to another bus devices, etc. And we can go to types of PLC. Types of PLC is of two types, based on power supply and based on input-output expansion. Now comes to based on power supply. With SMPS and without SMPS, there are two types based on power supply. With SMPS means the SMPS will be inbuilt in a PLC, so that we can give the 230 volt AC direct to the phase and neutral line in a PLC. In without SMPS, we should have an SMPS outside the PLC, which converts 230 volt DC AC to 24 volt DC. Then it is connected to the positive and negative terminal in the PLC. Then based on IO expansion. Based on IO expansion, there are three types of PLC. One is fixed, modular, and rack. Fixed type PLC, the IO cannot be expanded. There is no expansion port, so it can only have certain number of inputs and output modules, and the expansion are not usable in here. We don't have expansion port. We cannot expand it. So to avoid this, we came across modular type where IO can be expanded. From this, a communication port will be there, which that IO system can be expanded. Inputs or output modules can be expanded through it by a communication port. Then, but the disadvantage is in here: when the communication port fails, whole IO system will be suspended from the action, so we cannot control it. This is the disadvantages in modular type. That to overcome that, rack type is used. IO expansion can be expanded in parallel condition. So when one of the module gets failed, it can be removed and replaced with another module. So the CPU will have independent connection with every modules, so that every modules will be supplied without interrupting. So it is the main advantages of rack type. The rack type comes from the power supply, CPU, then the digital inputs, then the digital outputs, analog input, analog output, then all other input output modules. You can use like this. These two are mandatory in here. It can't be changed. Power supply and CPU can't be changed in rack type. The other modules can be changed. The programming language we use nowadays in industries are uh, 5 types, but we mainly use of 2 types. Let's see about it. First one is instruction list, structure text, sequential flowchart, then function block diagram and ladder diagram. These two programming are used in nowadays industrial usage. Let's see about that. The elements used in ladder diagram. This is an NC contact, which is not. It is an NO contact, which is normally open contact. This is the NC contact, which is normally closed contact. This is the output coil, and this is the memory coil. It can be any of that. So in NO condition, when the switch is on, the motor will be on. When the switch is off, the motor will be off. It is the negative rail, this is the positive rail, and this is the rung. And in NC contact condition, when the switch is on, the output will be off. When the switch is off, the output will be on. It is the NC contact we use. Then we move on to the rules followed in a ladder diagram. The first rule is addressing is must. We should address each and every input and output so that we can connect every input and output by the wiring. It will be easy to that, and there will be no confusing when we go to the wiring. The second rule is input can be connected in series or parallel. S1 and S2 are the inputs which can be connected in series or in parallel conditions. The third one is output cannot be connected in series, which means both load 1 and load 2 or motor 1 or motor 2 cannot be connected in series. It should be only connected in parallel only. Then there should be no gap between the rungs. Without if there is a gap, the connection will be cut, and when the input is on, the output will not be on, and it shows errors in the PC, in the software. It should be always connected. The fifth rule is output cannot be repeated. Once output is determined by an address, it cannot be repeated by the same address, and the same output cannot be repeated once again. But in sixth, input can be repeated with NC or NO conditions. Input can be repeated as we want, as an NC or as an NO. Rungs cannot be interconnected. The last rule is rungs cannot be interconnected. By this, if there is two rungs, it cannot be interconnected by the same line. Thus, it will create a problem, and also it will create some errors in it. So, this is the introduction to PLC, guys. I hope you enjoy it. Thanks for watching. Please comment, like and share, and if interested, please subscribe, guys. Thank you very much.